Hello to you all, and thanks for joining our Broadband Forum CloudCO 2021 demonstration. My name is Craig Thomas. I'm the Vice President of Strategic Marketing and Business Development here at the Broadband Forum, and I have the pleasure of hosting and introducing this year's demo. Now, CloudCO 2021 continues to exhibit the great contributions across many of the work areas here within the BBF, as well as the formidable work that's going on within our OB-BAA, that's the Open Broadband Access Abstraction Initiative. And you will see from the demo some great examples of how our work within that OB-BAA and the CloudCO environment is enabling operators to experience all the benefits and migration opportunities from their existing investments too, towards a service delivery that is truly virtualized, disaggregated, and enables zero-touch provisioning within a multi-vendor, as well as what you will see this year, even a whitebox environment too. So what can we expect from this year's CloudCO 2021 demonstration? Well, what we're going to see first of all is a CloudCO overview, and then we're going to take you through to a CloudCO functional network description, which will especially highlight DHCP relay and VNF distribution. Then we're going to look at what multi-vendor service creation and activation with that zero-touch environment truly involves. And then finally this year, we have a brand new application use case to demonstrate, which is game and session steering. But before we get into the demonstration, I would like to first of all just thank all of the active participation and participants from our vendor community, including Altis Labs, Capgemini Engineering, Broadcom, Nokia, UfiSpace, and VMware, as well as our supporting operators and consultants, BT, Reply, TIM, and Vodafone. And I'd also like to call out especially our Open Broadband Labs that have been supporting this initiative, EANTC, and the UNH-IOL that have basically been involved in this work from the word go and have given up their time and their resources free of charge to make this demonstration a reality. Okay, let's move straight into it. And I'd love to introduce to you now Bruno Cornaglia from Vodafone, who will be giving us an overview of why CloudCO is of real importance to the future planning of operators. Bruno, over to yourself.
Thank you to everybody. My name is Bruno Cornaglia, and I am the Fixed Asset Senior Manager in Vodafone. My responsibility is to manage the roadmap and evolution for the all access technologies, including copper, cable, and fiber. I'm also the work area director for SDN and MV Group in the Broadband Forum, where we are dealing to define all the specifications regarding print architecture and interfaces related to CloudCO framework. Okay, during this demo, we will see how we will instantiate broadband services towards our customers by using a Broadband Forum CloudCO framework. Here we will see an example among the ones that are available in order to instantiate a 1 gigabit high-speed internet services. The instantiation is done in an automated way in the sense that the service will be configured by using software-defined network. This means that the user and the services will be established by the network itself by using the discovery mechanism. So without any intervention from the user or from the operator side. Once the service is instantiated and is configured, any change will be done dynamically by the network according to the service that are used by the customers, without any need for intervention from the operator. Here we will see a lot of values that this approach have. First of all, zero touch. As already said, the elements are discovered by the network, and the network reacts to the discovery event. This means that the service is first activated with all the user equipment discovered regardless of where the equipment is attached. And then the subscriber section is automatically relocated based on the end user behavior. Then we will use also the software-defined network. So this means that together with the zero touch, the CloudCO specification are developed with the mindset that service activation and monitoring needs to be automated. In the demonstration, we see the relocation of the high-speed service once that the gaming session is started. Then we will see the disaggregated virtual functions. We will see here that in the picture that we have an example among the other by using the DHCP relay functions to be virtualized, not anymore into the equipment, but is in an external server. This allows for sure as an advantage by using the CloudCO framework to have the multi-vendor capability. This means that you can substitute, you can change part of the network without any need to make changes in other parts, because we have already developed specified a set of open APIs that allows to integrate rapidly new vendors into this framework. Then what is important is that in this open framework, we can also use open source software, because can be that part of this can be developed in an open source way. This means that at the end, you can integrate easily this open source software into this framework, because as you already said, we have a set of interfaces already defined, and that will allow these things. One of them is, for example, the OB-BAA that has been developed by Broadband Forum for decoupling the physical network element with respect to the access domain. Finally, that is really also important is that the CloudCO will allow to easily migrate from the current legacy network based on monolithic elements towards an open network based on distributed software, because this will allow to migrate these elements step by step by moving certain functions before, then to replace, for example, also the legacy equipment with whiteboxes or whatsoever, and then to have in different steps a complete CloudCO framework in your network. Here we will see as well the important thing is also the virtual OMCI that is allowed to separate the customer management, the ONT management from the network by having a virtualized functions that will help to manage this. Thank you very much for your attention.
So let's get into the demonstration itself. And first off, giving us a demonstration overview of this year's CloudCO 2021 is from our supporting labs, Karsten Rosenhovel from EANTC, and first of all, Lincoln Lavoie from the UNH IOL. Lincoln.
Thanks, and hello everyone. I'm a principal engineer here at the University of New Hampshire Interoperability Lab. I also currently have the privilege of serving as the Broadband Forum's technical chair. The Interoperability Lab is one of the Broadband Forum's open broadband labs, and we're hosting resources for the development of the next generation of broadband technologies and devices. So let me go ahead and share my screen and what we have built up for this year's demo. In this year's demo, the labs really have played a key role in the integration and coordination of the work. In addition to hosting many of the devices and resources for the demos, the labs have also provided a central point of connection and coordination for the demo components that are being hosted in other vendors' labs around the world. Over the past several months, we've worked with those teams to bring the CloudCO architecture into reality, expanding upon the components and features showcased from previous demos. First and foremost, before I dig into any of the technical side of this, I'd really like to say thank you to the contributors that have made this possible and the work that they've done to build up the demo. The demo is built from the ground up with components from both our vendor community, including Altice Labs, Altran, Broadcom, Nokia, Eufy Space, and VMware, along with open source components from ONAP, OSM, and the Broadband Forum's own OB-BAA project. The CloudCO framework was developed by the Broadband Forum to allow operators to move deployments to utilizing disaggregation and virtualization concepts. Key to this architecture has been the definition of standardized APIs and interfaces between the various layers and components that make up those networks. And it's these APIs that really enable the programmability of the network. So if we dig into this architecture a little bit more in depth, we can see the context of what the team has built up for the demo, and we can see that the overall layered structure of the CloudCO architecture remains. At the top level here, we have ONAP and OSM open source elements that are providing the functionality of the cloud domain orchestrators, where ONAP is providing service orchestration functions, and OSM is providing VNF lifecycle management for some of the VNFs that are being deployed into the network, such as the DHCP relays or the AAA functions. We use a simple business portal to show how the network operators folks would be able to submit orders and monitor services that are being orchestrated through the domain orchestrators. And then southbound of the orchestrators, we have the SDN controllers that are handling the programmability of both the access and the edge networks. The OB-BAA layer provides abstraction to the network access equipment that's being provided by Altice Labs, Altran, Broadcom, and Nokia. And what that means is that the standardized interfaces being presented to the SDN controllers become uniform and very well defined according to the Broadband Forum specifications. Also within the OB-BAA layer instance, we're running an open source reference implementation of the virtual OMCI specifications that have been developed by the Broadband Forum. And those virtual OMCI implementations are what enables the whitebox OLT that's being provided from Broadcom and Altran to function within the demo. On the right-hand side, we also have a Edge SDN controller that is a sample application that was provided by Swisscom, and that's interacting with the Edge BNG as well as the subscriber steering functions provided by Altran, along with open source components that are being used to provide the AAA services as well as the DHCP server functions. So from here, I'm going to hand you off to another one of our community members and the lab manager at EANTC, Karsten, to look more closely at the lab implementation and design of the demo.
Thank you, Lincoln. I'm the CTO and co-founder of EANTC, the European Advanced Networking Test Center based in Berlin, Germany. This demonstration uses the Open Broadband Labs in North America at UNH-IOL and in Europe at EANTC to emulate a functional distribution and hierarchical deployment of the building blocks. Such distributed data center infrastructures are typically seen in service providers' networks, and we aimed to model them as realistically as possible. So let me share the diagram with you. In this case, the customer portal and the domain orchestration function for service fulfillment and monitoring, ONAP, are located at the UNH-IOL. And the NFV domain orchestration function, OSM, is located at EANTC. We're showing that the domain orchestration functionality can be split and distributed across the locations. Obviously, we have a VPN connection between the labs, and we also have a VPN connection to other locations in this demo setup. So together, these represent the centralized data center of the service provider. Additionally, the access, SDN management and control functions that are comprised of virtualized components from Nokia, from Altice Labs and Altran, along with a broadband access abstraction layer, the BAA, are at the same location at IOL. These components represent the aggregated access edge location. The edge management and the control functions from Swisscom's open source project and the Altran subscriber steering functions are located at ENTC. And finally, the two BMGs are located in the UNH IOL lab and also at ENTC, showing how a subscriber session can be steered to a location that can provide a better user experience. These represent regional or aggregated access edge locations. So that's the lab setup. And prior to the COVID-19 pandemic, we had demonstrations on the show floor of the Broadband World Forum that housed the access and premises equipment. However, we can't do that right now anymore. So as already in 2020, this year, the demos are run on a virtual show floor, which is actually located at the participating vendors labs in India, in North America, and various locations in Europe, as you can see here on the left-hand side. The placement of these building blocks overall throughout the whole diagram is simply an example to show that the functions can be distributed to locations as appropriate. We chose these locations simply for convenience. For example, pre-existent infrastructure and services at the two open broadband labs. The labs have collaborated for Broadband Forum projects and generally for distributed and remote testing across multiple vendor locations, which has been set up at OB labs already since 2019. For example, there isn't any reason that the BAA layer could not have been deployed to the ENTC lab or even to the show floor. In the upcoming demonstrations, we will show the orchestration of the virtualized components along with the creation, the activation, and the monitoring of a 1 gigabit per second high-speed internet access service. Finally, this service is configured to include proactive monitoring of the subscriber session for fulfilling an expected or even agreed service level, which shows the power of steering the subscriber session based on a triggering event in the network.
So next, let's look at the network functional deployment itself. And supporting this scene, we have Andre Bazzido from Altice Labs. But first of all, from British Telecom, BT, is Antonio Marsico. Antonio, let's talk about the network function deployment.
Thank you for the introduction. I'm Antonio Marsico from BT Applied Research. As BT, we are contributing to the activities of the Broadband Forum from many years, and we are recognizing the potential benefit of the CloudCO architecture. The disaggregation of access control plane functions is opening new opportunities and challenges to network operators. It demonstrates that it could be possible to move from vertical integrated solutions provided by a single to a multi-vendor environment that aims to open the competition while driving down CapEx and OpEx for network operators. It is important to underline that this new architecture requires interoperability between the solutions that an operator has already in place, like BSS, OSS systems, and legacy devices. Domain orchestrators are the prominent solutions to reduce network complexity by offering a single management plane that abstracts the low-level configurations required by network devices. On the northbound, a domain orchestrator can be integrated with the operator BSS OSS by means of standardized APIs. For instance, TM Forum or HCNFV ISGI APIs. On the southbound, it could use either standard or vendor-specific APIs to deploy and manage the network functions. Open source has an important role providing vendor-independent solutions and driving standardization efforts. This is the case of open source Mano, an NFV orchestrator based on the HCNFV Mano architecture. It supports HCSOL specifications for both APIs and modeling of network functions. It can deploy network functions to private and public cloud infrastructures like OpenStack and Amazon AWS, and to the cloud-native infrastructures such as Kubernetes. By exploiting open source Mano, the type of infrastructure where the network functions are deployed is transparent to the network operator. In this demonstration, we are showing the abstraction provided by OSM when onboarding and deploying the DHCP relay network function. It is part of the 2021 CloudCO architecture. Andre from Altice Labs is going to show you how this works in practice.
Hi, my name is Andre Brizio, and I'm a senior engineer at Altice Labs. and co-chair of the OB-BAA development team. Altis Labs is an European software and hardware vendor, and our strategy is totally aligned with the WWF's CloudCO. The first step happens when the subscriber orders the broadband services through the service provider's customer portal and associated BSS systems. As part of the high-speed internet access service deployment, the virtualized functions that comprise the service are deployed using OSM to the Kubernetes environment. These are typically known as day 0 and day 1 operations. The ongoing configuration of the virtualized functions is performed through the CloudCO domain orchestration and access management and control functions. This demonstration starts by onboarding the DHCP relay KNF into OSM. Once the KNFs are onboarded, the KNFs are then deployed from the OSM instance located in Europe OB Lab into the Kubernetes cloud infrastructure located in the North America OB Lab. The same procedures and processes are used both for the KNFs of Altran and Altis Labs. Let's go into the demo. We are seeing the OSM graphical user interface. We start by onboarding the Altis VNF. We just drag and drop the descriptor. So the VNF has been onboarded. Now we onboard the Altran VNF. Okay, both VNFs are onboarded. Now we create the NS packages. Again, we drag and drop the descriptors. Both Altis and Altran are already onboarded. Then we go for the instantiation of the VNF itself. So we start by deploying Altis DHCP relay. We had some day 1 configuration. The VNF is being created. Meanwhile, we can onboard the Altran VNF. Right now, they are being onboarded on the Kubernetes instance running in UNH. The OSM is running in the European OB Lab, which is ENTC. Now we can check if both functions have been deployed within the Kubernetes cluster. For that, we can issue a kubectl command. You can see that Altran VNF is running, and also Altis VNF is running. So this concludes the onboarding of the VNF and instantiation.
So now that we've set up the network itself, let's look at how we do service creation and activation. And leading this is Tim Kerry from Nokia. And first of all, Francisco de Cavallo from Reply. Francisco, over to you.
Thank you for the introduction, Craig. And hello, everyone. Within Reply, I lead the strategy for disaggregated network solutions. Reply is an active and principal member of the Broadband Forum, with core business as a systems integrator and focus on agile development and CI/CD automation across all sectors of industry. For me, these sectors include telecommunications and IT. As a member of the board of directors of the Broadband Forum, it is my pleasure to introduce you to our latest community-developed and open source implementation of zero-touch provisioning. Zero-touch provisioning delivers the automation of service provision and activation for ubiquitous customer premises equipment. whether they be fiber or copper residential gateway modems. The demonstration you're about to see is fully compliant to our flagship Cloud Central Office architecture. CloudCO was first published as a global standard in 2018, and we are now in our 4th year of incremental reference implementations, continuously enhancing the baseline feature set, which enable our members to implement solutions with the assurance that they have the ability to reach a global market. Zero-touch provisioning is a must-have feature in any service provider network as it addresses a number of pain points for service providers. First and foremost, it enforces the needs for interoperability among suppliers and enables the real-time provisioning of the customer service, meaning that previous waiting times of weeks now happen at the press of a button as soon as the customer places their order. In turn, this reduces the operational costs for service providers by removing the need for costly engineering visits to customer premises sites. In addition, calls to the support desk from those customers who are less technology savvy can be eliminated. Service activation works simply by plugging cables in and flicking the power on. There's no opportunity for device misconfiguration, as the intelligence delivered by CloudCO compliant management and control platforms ensure that the device parameters are validated at the warehouse before it arrives at the customer premises. All in all, zero-touch provisioning delivers an automated process, leaving the customer satisfied with their service. And we all know that a happy customer will be more loyal and less likely to change suppliers. In turn, this reduces customer acquisition costs and protects investment, allowing service providers to reinvest in innovation. Aside from the improved customer service, we can also leverage the automation of zero-touch provisioning to deliver additional services such as bandwidth on demand and dynamic bandwidth management. We hope you enjoyed the demonstration, and please do come and see us at the Broadband Forum Pavilion, located in Hall 8, B10. Thank you.
Thank you, Fran, for that introduction in this demonstration of zero-touch service activation for broadband services. I'm Tim Carey from Nokia's Network Infrastructure Division CTO office. Deploying a broadband service in the network first happens when the subscriber orders the broadband services through the service provider's customer portal and associated BSS systems. For this demonstration, we utilize the broadband services use case that uses the ONAP open source platform to create and provide monitoring of the end-to-end aspects of the HISA service. In this demonstration, we see that the subscriber has the option to order a 100 megabit or a 1 gigabit HISA service that includes various features and devices as part of the service offering. For this demonstration, we will order a 1 gigabit internet service. Additionally, as part of fulfilling the subscriber request, the service provider allocates and ships to the subscriber the end user devices and then waits for the subscriber to simply plug in and connect the devices in the subscriber's home. While we are showing in this demonstration that the service provider ships their branded devices, the zero-touch operations are applicable for both retail and service provider branded end user devices. Since in some cases, the system doesn't know where the subscriber will attach in the service provider network, even when the system does know where the subscriber will attach to the network, the service provider might not want to allocate the resources until the attachment happens. ONAP keeps the service information waiting for the network to notify where the attachment is made. So we see that the order is created and is awaiting the subscriber to receive and plug in the devices that was shipped to the subscriber. Once the system recognizes that the devices that are shipped have been connected, it creates the service within the network by appropriately configuring the premises, the access, and edge segments. When the subscriber attempts to browse a website, the network authenticates the subscriber and activates the service. In this demonstration, the subscriber first activates the service. The ONU in the home is discovered by the OLT the ONU is attached to. The system reacts to the discovery by establishing a 1 gigabit service connection from the subscriber's home to the service provider's walled garden as the service awaits authentication of the subscriber's residential gateway before activation. Once the residential gateway authenticates the network to the network, the system triggers the connection of the subscriber's HISA service to the internet drain. In this demonstration, the subscriber is automatically authenticated when the device requests its IP address using the DHCP relay function. that can either be hosted in the OLT or can be disaggregated into the service provider's cloud network. In this latter case, the BAA layer acts as a control plane relay between the OLT and the DHCP relays VNF. The DHCP relay VNF can either interact directly with the DHCP server, or the DHCP relay VNF can utilize the OLT's user plane to forward the DHCP packets. In this demonstration, all three options of performing the DHCP relay are shown in purple. Where the disaggregated DHCP relay VNF directly interacts with the DHCP server, here we see the DHCP relay control plane flow is redirected by the BAA layer toward the disaggregated DHCP relay VNF. The DHCP interactions happen directly between the DHCP relay VNF and the DHCP server. Another option is when the DHCP relay is hosted within the OLT, as is traditionally performed. Here we see the DHCP relay control plane flow uses the HISA user plane to the BNG, which forwards the flow to the DHCP server. Finally, the third option is when the DHCP relay VNF uses the OLT's user plane to interact with the DHCP server. Here we see the DHCP relay control plane flow is redirected by the BA layer toward the disaggregated DHCP relay VNF. But instead, the DHCP relay VNF continues to use the traditional control plane between the OLT, the BNG, and the DHCP server for interactions with the DHCP server. By allowing for the various options, migration toward a separation of functionality within the OLT's control plane and user plane is achieved while accounting for coexistence with elements that use existing methods within the OLT. Once the activation has taken place, the order is considered complete. This entire workflow, from service request to activation, is zero-touch, and the time to activate the service is dominated by the time it takes the subscriber to receive and connect the devices to the service provider network. While the actual time for the subscriber to enjoy internet browsing, or as we will see in a while, a satisfactory gaming experience is much faster as compared to traditional fulfillment processes.
So finally, let's look at a brand new CloudCO 2021 use case. Kalamani Venkatesan from Capgemini Engineering will be going through a live demonstration of how dynamic session steering can be enabled in CloudCO 2021 within a gaming context. But first, to talk about the actual application itself and its importance is Mauro Toloca from TIM, Telecom Italia. Mauro, over to you.
Thanks, and hello everyone. I hope you enjoyed the demo so far. I am Mauro Toloca. I work with TIM, Telecom Italia, and I serve as member of the Broadband Forum's board, chair of the Service Provider Action Council, and story team lead of the OB-BAA project. Per the tradition established, with respect to last year's CloudCO demo, new capabilities are showcased today, which in turn demonstrate support of richer and more effective service offers. This last part of the demo aims at demonstrating the network capabilities to detect a change in the type of user traffic, check network conditions against defined service levels, and reprogram session steering to meet them, and preserve the user experience for this type of service, namely gaming. Session steering is key for service providers to automatically program the path of single or multiple sessions of user traffic across the edge, access domain, and possibly through the transport network. This, in turn, brings benefits in several service providers' areas of business. Specifically, it allows to provide new and competitive service offers, seamlessly and timely actuate assurance actions, anticipate network congestions via intelligent traffic balancing, and efficiently perform node upgrades and maintenance. The automatic and orchestrated actions across multiple network domains, notably the access segment, get telco operators beyond what some called dumb connectivity into a new era of monitored services and competition based on quality, even for consumer offers. The BBF is working on the session steering architecture and functions. That's working text 474, along with the disaggregated BNG specifications, Technical Report 459, Issue 1, and future issues. And now, I am glad to hand over to Kalimani of Altran to go through the session steering demo.
Thank you, Mauro, for introducing the gaming session steering demo. I am Kalimani Venkatesan from Capgemini Engineering Network Software Frameworks. Capgemini Engineering is a major contributor to the CloudCO OB-BAA activities, and we are thrilled to be part of this BBWF 2021 demo. Now let's see the gaming session steering demonstration itself. It starts from the user establishing a gaming session. And there are 6 steps in this demonstration to help understanding, as we have outlined in this picture. To start with, the type of the session itself is detected by the network using rules that have been programmed into the BNG's user and control plane. Once the network detects the user session carrying gaming traffic, it determines if the current connection can meet. Let us look at the gaming session steering itself. It starts from the user establishing a gaming session, and we have outlined here about 6 steps. That starts from the detection of a session, whether it is gaming, and moving on to which BNG needs to handle it. To start with, as step 1, the type of the session is detected by the network using the rules that have been programmed into the BNG's user and control plane. Once the network detects the user's session carrying gaming traffic, it determines if the current connection can or cannot meet the level of service for the subscriber service. It basically sends the information to the BNG's control plane. The BNG's control plane, in turn, interacts with the subscriber steering function to assess if the network can meet the service level. Then, the subscriber steering function may determine that the BNG user plane that is located closer to the subscriber's premises can handle the subscriber's service better for the gaming session. At this point, the subscriber steering function requests the traffic steering function, and that happens via the Edge SDN management control function to switch the subscriber to the new BNG's user plane. And the intent is to improve the latency of the subscriber's internet traffic. And this happens via the Access SDN management and control function, which is instructed to reconfigure the subscriber's session connectivity to the new BNG user plane. And finally, the traffic steering function in the access node switches the subscriber to the new BNG's user plane, and it improves the latency of subscribers' internet traffic. Let us now look at the demo topology itself. As would have been presented earlier in this setup, the end user traffic comes to one of the OLTs, in this case, the OLT that's shown here. And it is initially serviced by the centralized BNG, depicted here by BNG1. And when the session steering function determines the nature of the session and that it is better serviced, say, by BNG2, it makes the intimation to the Edge SDN, then the Access SDN, and all the way to the OLT, which in turn makes the configuration such a way that the traffic reaches the BNG2. This is what we are going to see in the demo. And before we step into the demo, let us quickly look at the two BNGs, the BNG1 and the BNG2. Both these BNGs are whitebox platforms from UFI space. They are based upon the Broadcom Qumran 2C silicon, and they run the Capgemini Engineering BNG NOS functions, BNG1 and BNG2. Now, onto the demonstration itself. There are broadly 4 steps in this demonstration, as we will walk through. It starts with the HSIA service going through the BNG1, and there will be a latency measurement. And then the gaming service would start, and the detection, as we described earlier, would happen from the BNG1 to the steering function, etc. So the gaming service steering and subscriber user plane switching, as we described earlier, it would happen onto the BNG2 control user plane. And finally, the latency of the gaming session when the BNG2 is servicing the steered subscriber will be measured, which incidentally would be much lower than the latency that we measured in step 1. Let us move on to the actual demo itself. The BNG configuration is being walked through now. Authentication is enabled, policy management is enabled, and the gaming server details are mentioned here. The DHCP relay is enabled with the BNG, and it's a global BNG server configuration, and also the Radius server on the BNG. With this, the IP address acquisition is happening. The client IP address, which we saw there, being recorded in the BNG1. The IP MAC and an SVLAN 400 is used here, SVLAN 400. The steering function uses this information as a heuristic. And when you look at the latency, it's about 22 milliseconds in this path. So the steering function determines maybe there's a better BNG, the edge BNG, and it triggers the movement. And when it does, it uses a different VLAN 410 in the access node instead of VLAN 400. So in the BNG1, the session has been removed, and it has moved into the BNG2 on the right-hand side, which uses the same IP address, whereas the SVLAN 410. The session is in the active state, as we can note. Session did not stop. And here, a ping test for the latency shows sub-millisecond, about 400 milliseconds. Sorry, it's 0.368 milliseconds, which is much lesser than the earlier latency that was recorded. Thank you for watching this demo, and hope this demonstration showed how a session steering can help move the session to an appropriate BNG and provide appropriate quality of service to the end user. Thank you for watching.